It'd be nice and leave
yeah.
it for them.
Except they won't know that you left it, and then they'll have to.
Well, it doesn't say grab a book.
There it is.
I did not see that.
Oh, yeah, I grabbed the book.
Hey, do you want to go on a book?
Oh, you just got to put it up.
I've heard this new substitution stuff is trippy.
This one?
Yeah. Like what we're about to learn. It's like kind of confusing. Some more. So it's a power. You've done that. They've done that so many times. We ran even at but the whole snowy track. It's like you kick it up after last year. It was like we're snow on the track and watching.
Well, I think it's back. Like, I think they got it. Like,
That's
yeah,
because
like a
wasn't
lot of
it?
people who live like around
I know,
Boston,
like,
like on
it was all in the
we went
stadium.
to California.
It was like ice. It wasn't just snow.
And then, well, we were going to go to work,
Lynchie would make us.
pasta about it, and we were like, whatever, there's zero like on yeah, like everything. We were driving like except for the sun. Like, which also like happened. Or honestly, or like maybe have some sort of like backpack battery type deal. That would want it. Did you?
Hear the change in it, just have the same.
What?
You can hear the change.
Oh yeah. That wasn't just spare change.
I had change in my wallet, and then I took it out of the wallet, so now it's going
That doesn't make sense. Why would you take change out of your wallet?
because I didn't want it in my wallet.
That is a very good solution. No.
I wasn't on it.
No.
You don't know this one.
I do not
I
care.
don't think you're gonna have enough time. I think it would be better to just...
No, I was like this.
It's not the best.
Yeah.
Yeah, Mr. Johnson is not gonna let you out like that. He will, but
Yeah, just go. Just go.
he wouldn't care.
I'll go in the middle of the class so I have to go.
Yeah, but I think he'll notice. He won't come back. Oh well.
Oh, I'm not gonna stay there. I just
Then just, why would you go there?
I forgot my AirPods.
Oh,
You haven't seen my voice.
Yeah,
This is Steven.
That's if I saw that.
That is a very nice specimen.
Yeah. I tried to make him a family, but they died. Gravity had a whole family. Steven's still alive. He's just very alone.
I got mine.
Yeah, he pushed it in class today. I'm like,
Alright, to get started today, I need y'all to find 73 from a couple weeks ago. Get out 73, please. Two, two, three. All right. So first off today, we are going to do one more FRQ from that packet of 4 I gave to you, and we had only had time to do 2 of them. So I do want to do all 4 eventually, so we're going to do one more today. Again, second semester, we put a pretty heavy emphasis on FRQs, since on the AP exam, that's where students feel the shakiest. Even a lot of times you guys do a fairly good job with multiple choice, but then sometimes trying to apply the same skills and stuff to FRQ, there's always a little bit of a disconnect. So try to squeeze in as many of those as we can between now and your AP exam. And of course, this stuff is still going to be relevant. Then we're going to start U substitution with number 81 that you guys picked up. U substitution is probably the single most important thing we do all year. I know our next assessment will have several U substitution questions. Typically, the last several years, the AP exam has had multiple choice questions on it, and at least one part of an FRQ has to do U substitution. So if I had to pick a single skill that you do need to be good at before the AP exam, it would probably be U substitution. So we'll practice that a little bit together on that handout, and then you can see the book assignment. It's actually a pretty long book assignment, but I have narrowed it down to just about 8 questions for the first day to look at, so that way we can kind of focus in on that. What I need. Okay, so we are on the 3rd FRQ. And I don't remember if I stapled this one for you or not, but this is what I intend to be the 3rd one. All right, so as soon as Ben's ready, we'll get started here. Ready? Okay, so a particle moves along the y-axis with velocity given by this. So we've got a velocity function, and we can't go backwards in time. Time starts at 0. In which direction, up or down, is the particle moving at t equals 1.5? How am I supposed to know if the particle is going up or down at that time? If what is positive or negative? Okay, so let's plug in 1.5 into velocity. Is 1.5 times the sine of 1.5 squared positive or negative?
Positive.
How do you know that?
There aren't any negative numbers here.
Sine of something can be negative.
That's a great point.
It is a calculator question. FRQ1, calculator. So throw that in the calculator real quick.
Since it's squared, we know that that's going to equal a positive number, then it's a positive number times a positive number. So that
But the sine of a positive number isn't necessarily positive. The
sine
sine of 5 pi over 4 is something negative. But calculator question, so we can just type it in. Now, I don't think it should matter in this question, and I have heard that they try to phrase questions where it should not matter as much. But if your calculator is in degree mode and you needed to say what the velocity was in this question, you could potentially get the question wrong, even though you know what you're doing. You need to be in radian mode. Anytime you're doing something trig related, sine, cosine, tangent, you need yeah.
What exactly does moves along the y-axis mean in that question, as opposed to like moves along the x-axis?
Sometimes the questions would just be like, you've got some particle and he just moves back and forth along this line, and then some questions it's just horizontal. Same difference. I mean, it doesn't really change much. If your velocity is positive, it's either going to the right or up, just depending on the question. And if your velocity is negative, you know it's either going left or down, depending on the context of the question. Since this is along the y-axis, we know it's going up or down, but they also put it in there, so it doesn't really change anything else, though. Okay, so you typed this in, and what'd you get? 1 point what?
1.6.
Okay, so what is your answer to part A and why?
It goes up because the velocity is positive.
up, velocity at that time is positive. So you had to do both parts of that to get the point in this one. I know we haven't looked at this in a few weeks, but the answers in the scoring guide are on the back page. So. Okay, so especially with the calculator there, they're just really testing, can you use a calculator, and then do you know about velocity and different signs tell you different positions. Okay, part B, find the acceleration at 1.5. How am I supposed to figure out the acceleration at 1.5?
Acceleration is your
Okay, so if I can find the derivative of velocity and plug in 1.5, then I will know the acceleration at 1.5, which is the first part of B. Now look at velocity. Is this something that we know how to take the derivative of? What kind of rule is that going to be? Product rule and chain rule within that, right? But this is a calculator question. Don't run the risk of messing it up, and don't waste your time. Just plug it in the calculator. Alpha window, option number 3, I think. Your calculator can do a derivative at a specific point. So type that in and make sure that you get, like, it's either negative 2.048 or 0.49, I don't remember. Is it 0.8 or 0.9? 0.9. Okay, so they gave 1 point for this. So again, this is what I refer to as very conceptual. Like, you're not having to do any of the heavy lifting here, but if you don't know the relationship between velocity and acceleration, and or you don't know that your calculator can do that type of derivative for you, then you may miss that part of the question. Okay, but that's not all for part B. Is the velocity of the particle increasing at 1.5? Now that's not saying is the speed increasing, not is it speeding up, slowing down, but is the velocity increasing?
No.
How come?
Because velocity is positive, but acceleration is negative.
That would be if it's speeding up or slowing down. I just want to know about velocity. Is the velocity getting bigger or smaller? What is the slope of velocity?
acceleration.
If acceleration's negative, doesn't that mean it's going down?
Yeah.
So the acceleration at this time is negative. Again, not to be confused with whether it's speeding up or slowing down. This isn't, is the particle speeding up or slowing down, because then we would see if they had the same sign. This is velocity speeding up, not speed. So, answer and justification. Again, justification is super to the point. Try not to overcomplicate it. Acceleration is negative when you're talking about 1.5. Okay, I feel like that's, I think last class said that they didn't agree with me, but I think this is probably the hardest part. So you guys okay with this? We don't need to discuss where any of that came from anymore. Okay, part C. So this is where we did a circuit on this a couple weeks ago. We've got y of t gives us the position of the particle for a time t. I know where it is at the start, and I want to know what it is at time 2. Or when t is 2. So, what would we put in our calculator to get that? Okay, if you integrate velocity, that would give you the change in position. But this isn't asking for the change in position, it wants to know the value of position at 2. I guess you could do that actually. You could integrate it. The problem is you don't know how to integrate this. You will today, but you don't need to go through that. I guess you could integrate it, put plus C, plug this in to solve for C, then you would have the exact position equation, and then you could plug in 2 to it. But there's an easier way to do this. Put what you're starting with. You're starting with the value of 2, plus we want to know how it changes from 0, t equals 0 to 0, t equals 2. You know, remember that circuit where we had to do this on every question? Starting value plus how it changes. This is
Wait,
what
why don't you put 3? Why'd you put 2 instead of 3 since it's 3 and 0?
it should be 3. I just careless. Starting value plus how it changes. Okay, and since you have a calculator and you have velocity function, just go ahead and throw that in and see what you get. Yep.
So why do you go 0 to 2? Is that just because you wanted to find y of 2?
Because I know the value at 0 and I want the value at 2. So this is like me saying you have $3 on Monday, and then you're earning money at a certain rate for Tuesday and Wednesday. So this is keeping up with how much it gains Monday to Wednesday, but you still got your starting amount of money that you had.
Okay, but how do we get that from the question? Because all it's asking is about the position, not like the amount or the distance traveled.
But if you integrate velocity, it tells you how the function below it changes. So integrating velocity gives you the change in position.
Okay.
Integrating acceleration would give you the change in velocity. It always tells you the change in the function below it. Okay, and if you did that correctly, it looks like it should be about 3.826 or 7? 7? Okay. I prefer that you always round to 3 decimal places, but if you look on the answer key, they always allow you to round to 3 or truncate to 3. So if you just cut it off and don't even think about if it rounds up or not, technically they still give you points. So this is a big one, and y'all are hesitating, so you might need to look back at that. That's a big topic. All right, and then finally part D. Find the total distance traveled from the particle from 0 to 2. I feel like there's a couple keywords in there. Total distance, absolute value. If I integrate just regular velocity from 0 to 2, this tells me how the position changes from 0 to 2. The problem is when it goes up, it adds to my distance, but if it's going down, it's subtracting from my distance. And that's not the way distance works. If you take 10 feet up and then 5 feet down, you didn't travel 5 feet distance, you traveled 15 feet in distance. So the only time you guys should be doing absolute value is when it says total distance. So throw that in and make sure that you get 1.173 or 4, either one. But you do need to know where absolute value is.
Wait, why would it be less than C? If it's like the absolute value, shouldn't the distance like add?
But this is a starting amount. Like this would be like you're starting at 3 miles or something.
Yeah.
Where you start has nothing to do with how much you travel.
Oh, so you don't add the 3.
You do not add
Yeah,
the 3.
okay.
Okay, y'all getting the same thing out of your calculator? Okay, so this one, again, I'm always going to emphasize this. In theory, you could do this one by hand with absolute value sign. If you guys want to look at what it would look like on the scoring guide, they always put it both ways. But on part D, you can either do this with the absolute value sign and get the answer, or you can do all of that algebra to get the same points. That's why I really emphasize the total distance. You need absolute value because it saves you from all of that. Basically what they're doing in here is they're having to take that function, find the zeros, figure out where it's hitting zero. Anything that's positive, keep it positive. Anything that was negative, make it positive. Add all that stuff together, and you end up with the same answer. So definitely not recommended, but possible. Okay, so before we move on from this one today, any of those parts you want to talk about again? Just overall, do you think this? Yeah, go ahead. What do you got? Do you have one?
Yeah, for BA had a hard time to find out how to get negative 2.049.
Okay, so in your calculator, alpha window, the same place where you can get your calculator to integrate some stuff for you. Right above it is for derivative. So I just did x, although you can do t, and then type in the function. So we had velocity. And since, and I wanted to know the derivative at 1.5. Because I know if I take the derivative of velocity, it gives me acceleration. And I'm asking my calculator, what's the derivative when x is 1.5?
Got it.
But you also have to be in radian mode. If you're in degree mode, it's probably saying something different. Okay, so just for my own knowledge here, do you guys think this is about average difficulty FRQ, easier than average, or harder than average?
Average for me.
A little easier.
Y'all have different things, I guess.
A and B were easy, C and D were pretty hard. I couldn't think about that.
Really, D?
D wasn't that hard.
Well, because D was hard because I didn't know what C was. Oh, just kidding. Never mind. I didn't know. It's just C.
Okay.
Like, I couldn't think about that on my own.
All right. Well, that's kind of what last class said too. So I'll try to emphasize that as I see opportunities the next couple of weeks. This type. I mean, we did a whole worksheet on them. We spent a whole day on it.
No, I'm talking about like these FRQs.
Oh yeah. I mean, I agree. I would love to give y'all 10 of these for homework. I just didn't think that y'all would appreciate that very much. We will probably do 20 of these, 30 of these before the AP exam. The problem is that they're all slightly different.
Oh, yes.
Okay, let's move on to.
Do you think there would be an accumulation question in the exam? Is that almost always on there?
And the way that integration keeps up with your accumulation, absolutely. I mean, that we just saw that on the last. It didn't use the words accumulation on the last one, but part C was here's your starting value, and then integrate to figure out how it adds up over time. Yes, that'd be multiple choice and probably FRQ. That's like one of the most useful things for integration. Okay, let's move on, please. All right, so before we start the U substitution notes, I want to kind of talk about this. I know you're used to seeing X's instead of U's, but how would you integrate something like this? Times what? Okay, raise the power by 1, divide by the new power, plus C. You guys can do that, right? This question that I just wrote down is almost question 1 on your notes. Once you learn a couple steps of U substitution, that's literally what we're going to do. We're going to make this question look like this because we can do this no problem. We've practiced this for weeks. It's just that it doesn't look correct yet. So for question 1, we've got to start off all of these. Well, first off, not every integration question is going to be U substitution, so don't fall into that trap. I would say, 25% of the time you get a calculator, let your calculator do it. Half of the rest of the time, it's going to either be undoing something you have memorized or undoing the power rule, and the other half of the remaining time is going to be U substitution. So don't just think that it's always U substitution from here. But first thing that we got to do is pick out a value for U. And U is usually something that's trapped under a square root, trapped inside of a trig equation or trig function. In this case, probably this stuff under the cube. So So go ahead and say u is x squared plus 1. The next thing you need to do is you need to take the derivative of both sides of this with respect to x. So take the derivative of u with respect to x and the derivative of this stuff with respect to x. Now since this is dx over dx, we don't usually keep up with it that one. And then finally, multiply both sides by dx so that u stuff is on the left and x stuff is on the right. You have to write down those steps. This is what you heard. Anything that's on the board. Okay, then what we're going to do is we're going to change the way this question looks. So instead of having all of this stuff cubed, I'm going to say it's u cubed. And instead of saying 2x dx, I can say du. You see how those substitute into those places? It's kind of like fitting together puzzle pieces.
Is that just by chance, or how does that?
It's not really chance. I mean, I made an educated guess on what u is going to be. And again, it's usually the thing that's trapped under something.
How do you recognize you?
It's usually the thing that's trapped in something. You'll see after a few of them.
So you don't have to bring down the dx.
The dx, 2x dx got replaced with du. That's why you need the dx in this work over here too. Instead of 2x dx, I could just put du. It's a perfect substitution. There's not anything I'm ignoring. Everything fits. I'm trying to color coordinate it to help you see it. Are you okay with how this became u cubed? Are you okay with why all of this became du? What you got?
Why did you take the derivative of the stuff in u?
Because I needed to figure out what all of this stuff was equal to so I could make this substitution. And by taking the derivative of both sides, it creates a du and a dx, which allows me to solve for those things.
Oh, okay.
You'll see, it'll happen every single question, so y'all won't worry about that. Okay, well that's the challenge here, so this is what we're going to try to get better at question after question. But now we've got it written like this. We can raise the power by 1, divide by the new power, put a plus c, and the last thing keeping us from our answer, u substitution is just a technique that we're using to get the answer, but we don't really want u's in our answer. So we're going to put this back in, plug u back in, or x squared plus 1 in place of u, and then that gives you the answer to your question. Yeah.
What happened to the du?
It goes away when you integrate. The same way, like if I integrated this, you raise the power by 1 and divide by the new power, the dx goes away when you integrate.
Okay, that's cool.
All right, and again, I'm not going to do this each time, but I certainly recommend that you guys do this occasionally, if not all the time. How can we check this answer?
Take the derivative.
And if I did the derivative, I would bring the power down, lowered the power by 1. What else?
Multiply by the derivative of the inside.
Okay, and the derivative of the constant is,
0.
and do you see how that's what we started with?
That's crazy.
It's pretty much magic. Okay, so question 2, we got to practice picking out what u is. We've got to practice this part, because if we can get it to be in terms of u, then it's going to be the way that y'all have been practicing for
So
weeks.
is it like really mostly like when there's an instance of chain rule?
Yes.
That it,
This is allowing us to not have to try to undo chain rule in our head. It's also allowing us to not have to try to undo product rule or quotient rule backwards, which would be insanely hard. This one process takes care of all of that for us. Okay, so number 2. What would you think, what looks like it's inside of something in this question?
Just a 5 or 5x.
Okay, probably 5x. Now, I'll be honest, sometimes you think you know what u is, you pick it, and then you figure out in a moment that it just doesn't work. So you're going to do this, then you're going to take the derivative of both sides with respect to x, and you're going to multiply the dx over. This way I know what du, or I know what u is in terms of x's. If we picked out the correct u, then all of this, it won't just be close, everything will have a very perfect fit. You need to keep up with this stuff exactly, because when you don't know that you don't have a perfect fit. But in place of all of this, I can call it cosine u. And what is 5 dx equal to? 5 dx is du. That's why I have to do these steps, so I know what du is equal to. So I know that this 5 dx can be replaced with du. If you don't take the derivative of both sides, you're never going to see that. Okay, well, what can we take the derivative of to get cosine of something? Okay, since we don't have bounds, we need a...
Doesn't it be negative? Negative?
The derivative of sine is cosine. You're thinking the other way. And then the only thing not okay with this being your final answer is nobody asked you anything about u. We just did that as a convenience thing. You need to plug that back in. And I guess if you have time, you can take the derivative to see that it works. Even the chain rule has been accounted for. Yep.
I didn't see, like, what happened to the 5 in front of the cosine?
It's right here. It's part of this 5.
Okay.
That's why I'm trying to underline the red and the purple, so you guys can see what part's coming from u and what part's coming from du. But also you need to see that everything has been accounted for. I'm not just ignoring this 5 and hope it works out. I know 5 dx was du. So this and this went away to create that, which I need because when I integrate, I need these variables to match up. I don't want to do cosine u dx. That doesn't make sense. We need those to match up. Okay, question 3. What do you think u is going to be in this one? Okay, good guess, because it's inside of something to the 4th power. Again, doesn't mean it's 100% true or going to work, but it's by far the best guess. Take the derivative of both sides with respect to x, and then solve for du. So just multiply the dx over. After a while, I'll probably start skipping this step and just put the dx on the other side, but last year students didn't know where that was coming from. So, all right, now I want to try to replace everything.
Isn't it du over dx equal to x, not 2x?
The derivative of this with respect to x is this. The derivative of this with respect to x is this. Derivative of x squared is 2x. Derivative of the constant is 0. Okay, so in place of all of this, what can I say?
1 over 5 u.
Just u?
1 over 5 u over 4.
No. U to the 4th. This is what I'm calling u, so this is u to the 4th. Okay, the other replacement, so this is going to take an extra step on this one. I also need to plug in for x dx. Do I know what x dx is equal to? You need to write this step out. Too often I see students skip this and then they don't know where this 1/2 is about to come from. I need to make a replacement for x dx. So when I put this right below it, I can see I'm dividing this side by 2, which means this side needs to be divided by 2. In place of x dx, you have to replace it with 1/2 du. If you just throw in du, just because it's convenient, you're going to miss half the questions.
Why did we divide by 2 on the 5?
Because we didn't need to. It was a perfect fit. I needed a 2x dx, and that's exactly what I had. This one, I needed a 1x dx, but I had a 2x dx, so I needed to divide by 2, so I divided by 2.
So
Yes.
you put the 1/2 up
David, what's your question?
Why don't we have to in front? Instead of like.
You can put it here if you want to,
Ooh, right there.
but most people, when you integrate something with a constant, it's the same as the constant times the integration. So it just makes the integration a touch less
It
messy.
doesn't make it.
You got it.
Okay, so now everything's in terms of you,
It's
guys.
a nice touch.
It's okay if this is going to end up being hard, but I'm not going to be sympathetic when y'all are continually talking. Okay, so now notice everything's been underlined, everything has been substituted, everything is in terms of you. So now I can work it like I always have. Raise the power by 1, divide by the new power, put a plus c because I don't have bounds, and my answer shouldn't have a u in it because I know what u is equal to. 1/10 times x squared minus 3 to the 5th plus c. That's what you could take the derivative of to get x times x squared minus 3 to the 4th. And you're welcome to do power rule, chain rule to see that it works. So again, I'm not too focused on this. This you've been doing for weeks. This you're going to continue to get better at. But this picking out of you, seeing why you need to do this, and seeing where this 1/2 came from. If you're not paying attention and you don't force yourself to write this step down, if you guys come to me in advisory next week and you say, I don't know where this 1/2 came from, and you're not writing this step down, I can't help you. I can't just tell you where the 1/2 comes from. You've got to solve it for what you need. If you need an x dx, you need to make it say x dx. You need to see that you're dividing this side by 2 to understand why you're dividing this side by 2. That's what's undoing the chain rule for you, so that you're not trying to undo insane derivatives in your head. So that makes it way easier overall. Okay, one more of these, and then we'll look at what happens when there are going to be bounds. Now this one's a little bit harder to see u in this case. I think it's because of the way we write trig functions, but cosine squared just means you're squaring cosine. So to me, the thing inside is probably just going to be cosine because it's trapped under a squared. I don't know if that's correct until I actually figure out what du is and try to change all of this to u stuff. But I'm also not going to know just sitting here, so I got to try something. Okay, what do we do after this step?
Derivative of u with respect to x.
Okay. Oh, and the derivative of cosine is negative sine. What do I need next?
Change the dx over there.
Okay. Multiply both sides by dx. That way all the x stuff is on one side, all the u stuff is on the other side. Sometimes you're ready to make all the substitutions you need to, and like questions 1 and 2, and sometimes we need to go one step further. I've got to look at what I have. So instead of saying cosine squared, I could say what?
u squared.
Okay. U squared, because that's how I defined u. And do I know this is what's left over? This is the parts I have to find. Do I know what sine x dx is equal to?
No.
But almost.
Negative du.
So write it down. Maybe in a week, if you're super confident, you can skip this, but I promise you this is the biggest mistake students fall into, is not writing it down. To get from this to this, I need to multiply by -1, and if you multiply one side by -1, the other side needs to be multiplied by -1. Sine x dx is not equal to du, it's equal to negative du. By doing it this way, it's like an algebra 1 problem in front of you. It's a lot easier to keep up with. Okay, and then the integration's no different than we've been doing. Raise the power by 1, divide by the new power. We don't have bounds, so put a plus c. And before I circle that as my answer, what else should I change?
You put the u in.
Okay. Plug in what u was, And if it's an important question like a quiz or a test and you have time, you could take the derivative. Doesn't really take that long, but make sure you guys do that occasionally because it's good for y'all to practice this chain rule and stuff since we don't use it a ton this semester. Yes?
So, why do we take the derivative with respect to x?
Because how else are you going to, if I'm trying to substitute for this, where does dx come from if I don't do that? I'm asking you. I need to replace dx.
Yeah.
So by taking the derivative with
I see.
respect to x, it creates my dx here that I can see where it fits.
Okay, that makes sense.
And it also helps us keep up with everything. So, okay, so it is just a touch different if we've got bounds, but the first part's not going to be any different. So in question 5, what is you going to be in this one?
X squared plus 2.
Okay, so try it. Take the derivative of both sides with respect to x. I'm just going to multiply the dx over so I can skip a step. I'm going to try to make this look different. So it looks like I've got 1 over u to the third. All of this is u. And then the other stuff I need to replace is x dx. Is x dx equal to du?
No, but 1.5.
And since I did that, since I took the derivative of both sides, I can quickly see that. I want 1x dx, so I need to divide this side by 2, so divide this side by 2. 1/2 du is the same thing as x dx. Again, this process is doing all of that for you. If you make a guess for u, take the derivative of both sides, solve for exactly what you want, it will work out every time where you're not trying to juggle stuff in your head. Okay, I'm going to go ahead and rewrite this as u to the -3 just because that's how I would go about integrating it. But here's what's a little bit different that we need to highlight in these steps. My bounds are no longer 1 to 2. They are now 3 to 6. Where am I coming up with 3 and 6? Yeah.
Because you took half of the respect to you, so you have to double. So, wait, what? No, never mind. I was thinking weird.
I think you might have been close. What do you think?
You took the exponent 3 and multiply it by the 1 and the 2.
The exponent 3, no. Okay, the original question is all in terms of x, correct? So it's 1 to 2 if you're talking about x. When x is 1, when x is 2. I changed it to u's. So when x is 1, what is u equal to? When x is 1,
Oh, x squared plus 2.
3.
u is 3. That's why the lower bound became a 3. And when x is 2,
That's 6.
since we're changing the variable, we have to change the bounds as well. 1 to 2 is if you're talking about x. I'm talking about u, so it's 3 to 6, because that is what 1 and 2 for x is 3 to 6 in u. So you have to plug it into your u definition up here. Okay, and I'm not even going to finish this one, but we could raise the power by 1, divide by the new power, evaluate it from 3 to 6. So we would plug in 6 the first time, plug in 3 the next time, subtract those, and we could finish the arithmetic if we needed to. I'm not worried about the arithmetic though. The main thing is I need y'all to highlight this in your notes. If you've got bounds, 1 and 2 became 3 to 6. You got to plug them into that formula for you. Yeah.
How did you get from like your last 2 steps together, like the negative 1/4 to you?
Well, I said -1. It's -1/4 times all of this, so -1/4 times all of this. If you plug in 6, 6 to the negative 2 is 1 over 6 to the positive 2. Six squared is 36.
Oh, and so you're just subtracting these two sides. Okay.
Yeah, I'm plugging this in, doing the arithmetic, a little bit of the arithmetic, plugging this in, doing a little bit of the arithmetic, and I'm just not finishing the arithmetic, but yes.
Why is it -1/4 instead of -1/2?
Because I had a negative 1/2 out here, and then when I integrated, I had to raise the power by 1, and then divide by the new power.
Okay.
So it became negative,
On the AP exam, couldn't you just leave it like that?
like what?
That?
Unevaluated? No.
No, like -1/4 times.
Oh yeah, technically, if it is FRQ, yes, you could quit there technically. In fact, they encourage that. You don't have to add, you don't have to do any arithmetic for FRQs. You can leave 3 plus 5. You don't even have to say that as 8. But multiple choice, I mean, half your points come from multiple choice. You know multiple choice is going to go further on that. All right, let's try that again. 6. What's a good guess for you on this one? See, that's not too bad.
That's great.
I mean, it was magic 20 minutes ago, so.
Still my chance.
I mean, a little bit is. Sometimes you're going to guess U and it's just not going to work, but you'll see that it's not going to work. Take the derivative of both sides, multiply your dx over, so all the x stuff is on one side and the u stuff's on the other side, and then we're going to hope that everything just kind of fits into place here. So instead of this stuff, we can say what? Square root of u. And in place of this stuff, we're going to say du. It's a perfect fit. It's exactly what I needed. I can see how these pieces fit together because I've got it written out over here. And this is not correct now. What did I not consider? Right, we've got to update the bounds. So it was pi to 3 pi over 2, but that's when you're talking about x. So to figure out what that is as u, you've got to plug it in up here. So if I plug pi into this, we get 0 plus 1. So that's my new lower bound. Plug in 3 pi over 2 into this, you get negative 1 plus 1. So my new upper bound is 0. Use this, how you defined u, plug in those x values to solve for your new u values. Then you can raise the power by 1, divide by the new power, plug in the top bound to get 0, plug in the bottom bound to get 1, subtract those. You can do the arithmetic, negative 2/3. But the main purpose of this is we're taking a question that would be trying to undo derivative in our head and allows us to have a process that if we follow those steps, we are not having to undo chain rule in our head. That's why it's so helpful. Okay, again, arithmetic part, I'm less concerned about this. So, yes.
How did you do the arithmetic part?
Which part?
Like when going from u to the 0 minus 1.
Okay, so I plugged in, I had this 2/3, so I knew it was going to get multiplied to both parts. I plugged in the top bound first. So 0 cubed would be 0. The square root of 0 is 0, so that's where I got this 0. Then I plugged in 1. 1 cubed is 1. The square root of 1 is 1, so that's where I got that 1. And then you always subtract those, like we've been doing.
Okay, cool. Thank you.
Yep.
Wait, so do you plug the bounds into the u, so you don't use like u equals sine x plus 1, then plug in the bounds?
Correct. And in fact, if you want it, after you integrate, if you plug this back in place of u, then you better use the original x values, because then you're doing it in terms of x. But you can do that. I just do it this way just for consistency, just to do it one way. What he was saying, if you didn't hear his question here, is if you change this u, which again, I don't understand why you would in this type of question, but if you make that substitution back, now this is in terms of x. So you better keep the original bounds if you're going to do that.
Same answers?
Should be the same answer. Okay, one more, and actually on this one, why don't you guys try to do one step before me? So pick out what you think you should be, and then we'll check it. And then this way you can at least see where you're getting hung up and where you need to put some more focus. Okay, did you pick x squared plus 1?
Yes.
Okay, keep going. Whatever you think is next, do that next. Your next step was to take the derivative of both sides with respect to x, and then separate your variables, get u stuff on one side, x stuff on the other side. So make sure you did that before you move on. Okay, your next step was to try to use this stuff as puzzle pieces to replace everything here. You don't want to see any more x's anymore, and everything needs to be a perfect fit. We're not pretending like something's not there. Everything is being accounted for. So in place of all of this, you should have said, we can just call this cosine u. And then the other stuff you needed was x dx. X dx is not du. If you write this down, that's obvious. X dx is not du. If I want x dx, I'm dividing this side by 2. So divide this side by 2. 1/2 du is the same thing as x dx. That's the substitution that you can make. Notice everything in the original question is underlined and accounted for. The underlined purple stuff became my purple stuff, and the underlined red stuff became my red stuff. Okay, keep going.
Wait, why does it work like that where you can just stick the 1/2 on the outside? Like, why is it equal to, like, the same as if it was on the inside?
Well, it's the same way as derivatives. What's the derivative of this?
4x.
Okay, or, and I'm assuming you brought the power down and then lowered. What if I just want to do the 2 later? What's the derivative of x squared?
2x.
You see how it's still 4x? It just, dealing with the constant at the end is easier than squeezing in an integration and then confusing if that's something we got to account for. Since the constants work that nicely. Okay, what came after this?
The changes the bounds.
Good. You got to change the bounds. So 0 for x became what for u?
1.
Good, because you got to plug it in here and solve for u. When x is 0, u is 1. And when x is 2,
Use 5.
u is 5. Plug it in here and solve for u. That's your new bounds. Okay? And now, I'm not saying it's easy from here, but from here, this is what we've been doing for weeks. Now we can just say, I could take the derivative of sine to get cosine. If I want to evaluate from 5 to 1, one time I'm going to plug in 5. The next time I'm going to plug in 1, and then I'm going to subtract them. Sine of 5 and sine of 1 don't simplify, so you can't do anything else with that, as much as you may want to. Yes?
After you take the, like, antiderivative of cosine, don't you have to plug, like, x squared plus 1 back in for u?
You can if you want to, but if you plug this back in place of u, you need to keep your bounds 0 to 2. Down here it doesn't matter because we're going to end up with a numerical answer. Up here it mattered because we didn't get a numerical answer. We could just put the plus c. So we needed our answer to be in terms of x here. So you can do it either way you want to. I'm just not doing it both ways just for consistency and to simplify the process. If you want to plug this stuff back in for you here, don't change it to 1 to 5. Leave it 0 to 2. You're balancing to match your variables. There's just no need to plug it back in if you're going to do it this method and get a numerical answer. Okay, I want you guys have been asking great questions today. I appreciate that, but you need to look through this one more time. On the agenda, I mentioned a mini quiz next class, so I am going to give you one question like 1, 2, 3, or 4, and one question like 5, 6, or 7, and it'll actually be the exact question. It'll either be question 1, 2, 3, or 4, and then question 5, 6, or 7, depending on which form you get. So for the first time, I'm showing you exactly what it's going to be. And we'll probably do several of these, but the first one will just be 2 points, but I'll make a major point so that it's a little bit more meat on the bones for that. So, with that in mind, is there any part of one of these you would like me to discuss again? Yeah.
So, kind of on our last one, when it came to plugging in like x dx, you can pull from any part of the equation. You know, you'll see like the purple's underlined at different spots and the red separates them.
Okay.
Those
Yes.
can be like, you know, moved around and.
Yes.
Okay.
Because right here, like, remember the order of multiplication doesn't matter.
Right.
So if you want to call this x times cosine of this stuff, or if you want to call it cosine of this stuff times x, like if it makes you feel better, if the x is next to the dx, then you can, but it doesn't matter. Okay, then if I was you, I would, at the top of your page here, give yourself a little note about that mini quiz. Again, it will just be exactly one of those, so you guys have a very narrow window of things to look at. And it just depends on which form you get. It depends on which question you get. But it'll be 2 questions from this, no deviation from it from the first time.
31st, Tuesday?
If that's the 31st, yeah. Okay, and then finally, I've got like 8 of these I'd like you to try. Now keep in mind, this question type, just like we did on the FRQ at the start of class, there are some times on the AP exam where this will be on a calculator FRQ. So even though we can do U substitution, if all we need is the number, remember your calculator can do this type of question for you, right? It can do definite integrals. So I think like the last 3 book questions, I've got like 8 of them, but I think the last 3 are that type. So you're welcome and encouraged to compare your answer to what your calculator answer is. So go ahead and copy this down to 82, please, and start those and see how they go. This I'll let you work a little bit more at your own pace on it. But there is more to this book assignment. It's just that this is the part I'm asking you to do between now and Tuesday. We're going for quality over quantity here.
Oh, let's go.
Check in the back book. Or you can just take it. Might be faster. Or the back side of it. Most of these are odd, so you can check in the back of the book. You can also. It's good to do a few times. And the last couple you can check by throwing them in the calculator. There's only 8 questions total here, so.
You have to simplify it all this.
Because it goes away no matter what.
Let me look at what he's talking about.
So that, or the antiderivative of that would be 3/2, and then that's u, and then 2/3. But if you take the derivative of that, that'd be like 2 over 3 times 2, 2.
Why 2 over 2?
Because it's you taking it by 1, guys.
When you're taking the derivative, you bring the power down, then lower it by 1.
Oh, okay.
So 2/3 times 3/2
And
is
so
going
it's
to
still
be 1.
going to be 1 and 1/2. Yeah.
Yeah. What do you mean?
Like in question 7, just like down to that, is that good?
Yeah, that's fine.
Okay.
I mean, I guess you could write it as a square root to the over 2 if you wanted to, but I don't know, that's more simplified. I guess it takes 1.
Oh yeah, they look good.
You get started. Are you worried about the C part or the other part? I probably wouldn't distribute it unless it's multiple choice and it looks like the distributed. But on this, if you do negative 1/3 times the number you don't know, it's still gonna be a number. So you would still call it plus. You're not gonna call it negative 1/3. You're just I'm saying you can either leave it like this, or you could say negative 1 pages. That's pretty clean. Yeah, so you can do that. It's all the way up. Negative 1/18. Step position. Plus the, I don't say minus 1 or something. You just those. Right.
I guess I'm just numbers. Is this 100 plus C variables? It's just kind of format all the I see as it is.
Yeah, I mean, they probably would multiply these two and call that negative 1/18.
Okay.
But her question was like, does this go to the C too? And technically it does, but negative 1/3 times a number you don't know is still a number you don't know, so we still just call it C.
Okay, cool.
So when you check it in the back, they're not gonna call it negative 1/3 C, they're just gonna still call it C.
Okay.
What's it mean to solve a differential equation?
You don't necessarily know what to do with the same without the same question.
Solving a differential equation, you define the function. So they're asking you to integrate this stuff. So you can integrate that by hand quickly. That's but that term is gonna be. But they're giving you what y prime is equal to and asking you to figure out what y is equal to. You're doing the same skill, it just worded this, you're doing the antiderivative. This, you're doing the antiderivative. The question starts with this.
But then, like, whatever I do, it's gonna be plus away.
Oh, 10 to 5.
Integrate the two terms. The right one is constant.
We're gonna forward.
I multiplied by negative.
By negative, we're not leaving one-third.
Oh, 1/6 minus negative 3.
Yeah.
Is negative.
Why are you wanting to divide?
Because what was negative 1/6 times 6 is 5. And like 6 and 5 does that
Now check in the back.
Yeah.
Okay.
Okay.
Check. That's what snow is.
And we get enough
So
now?
use that for your negative.
Negative 1.
Oh, wow.
Why don't you use that for your?
How much, like how far do you have to go to get that much snow?
Okay, so you go.
It was like really steep snow, so you probably rolled that thing for like 50 feet.
That would.
You were like in a circle.
Dude, the snow this year was
Did you see my story?
Yeah, no, it's prime snowball.
Insane. Yeah. What?
Where by all those people?
They drove to my house because the roads are
Squared,
fine.
right?
Okay.
Yeah. Yeah, okay.
Oh, wait, sorry.
We lived in
Because that would be.
I live right by the lake, so like I never lived out.
Really?
There's like a 1 mile road, like
I-
someone has a fountain gun, a electric pole between us and then.
And then that would be the only way.
I know you're wrong.
Oh, we y'all old enough to remember the ice storm?
I remember the ice. I barely remember that.
You should negative.
I remember jumping off my dad's truck into the snow on the driveway. Looking over. And then like
That explains a lot.
and then we lost power for like 2 days.
2 days? Somebody lost for like 2 minutes.
It would be 1/6 equals 6, and then you can multiply that by.
Really? We didn't have day school like Monday and Tuesday, just Friday.
And then you
I was
I
so
think it was like
happy.
2 weeks, almost. 2 to 3 weeks.
And I remember it being hot out, but the ground was so cold there was still snow.
I didn't get the rest of
I
that.
remember it being warm.
I don't remember.
To the 6.
Just that I didn't leave power.
16.
How are the first couple going?
Okay, that's good. Then subtract it for negative 1/6 minus
You need
1.
for 2033.
So I keep taking this.
Do you want to check? I'll check.
But what if we don't get to them in class?
Oh, it's a differential equation.
Yeah, so we will.
Yeah, so we're from down here to here. So I know it's 4x times u.
Oh, that just means find the original function.
Oh, but it's my negative 2.
Okay, it's a differential equation. So it's giving you, it looks like it's giving you the derivative. Let's see, find the original function.
Ah, the original.
Yeah.
Before.
So then you would take the
So
integral
then-
of 4x.
I can do.
That's what that is.
Yeah, so you haven't really integrated here, so you need to keep up with, you need to write this, you still have the integration set.
Right here.
So what if you?
I'm just rewriting it. You don't have to.
I already did.
X squared, and u equals 6.
I mean, I would probably put the constant out front, but as we get today, it doesn't matter.
So 2x plus.
And then 27.
Just a negative.
But then I can plug in.
No, I know. We have to like do it.
You need to integrate integrate it. You need to worry about one divided by the new power.
So integrate the whole.
Doesn't like
this.
You can never integrate.
Okay, but
Yeah, once we've integrated this.
here's the problem. So we have to do.
Rewrote it
I don't know how to install that.
so that it's written in a way.
Yeah,
you
that's
can
the part
integrate
that got
it.
stuck.
There's 4x plus all that.
And is this negative 1 half is true, this is U right here. Where is it?
What are you confused about?
There's no DX.
The power only goes down out front to everything.
Oh wait, there's right here.
Here's part of 1, so it's 1 half. Divided by the power, so 2
Oh wait. No, when you were
Do you know if there's another lecture?
DX right there.
Probably. No, divided by one
I
half.
never forget.
They're not that, that's why they're not
See
that
what I'm
bad.
saying?
Yeah, she doesn't enforce it. I literally
Yeah.
listen to music.
Okay.
I really don't, I like, I don't like
We're taking
the
math to go above
I
this.
hate that. This picture is a nice picture.
I love her.
Yes, I can, also I can get the nuts out.
Here is
What chapter are you on?
So you have to rewrite the
I haven't started.
DX.
Oh, wait, no, I have like 3 pages of notes.
Dude, that's even worse than me.
I know, I've done barely at all.
We add those together.
Okay. For DU.
So we gotta make this.
No, because you're really integrating this as two. The thing that you can take and get
So
rid
DU
of
negative 2. But we need it to equal 4x
Multiply
dx.
by -2.
We need it to equal 4x
figuring out
dx.
the original
So
summation,
negative
which is what it's at.
Yes.
So you got y to do it.
Multiply by -2.
Negative 2 du equals 4x dx. dy
I don't know how to do that.
Did you do 1 over? Did you do 1 over?
You can just make it on
I see it on
Yeah, it's different here.
Are you serious?
Huh?
Okay.
So right, 27.
A little bit of
Just sit
tomfoolery.
Here. You do this as your u, and then dx. So this turns into dy, and this turns into 4x dx, and then 4x dx. Okay, and then you need to use u.
Here, hold on. So I don't know. If I have it right there in the.
Well, I don't know.
So
Race is fine. I don't know where you're.
here,
It's like you're trying to
you
do
get,
right there.
I just read it.
And I don't tend to write it.
Yes. So u.
So 2x.
So this definitely what I've been doing outside.
And then negative 2 du.
Negative 2 du equals 4x.
Is this your u?
Yes.
Let's just see
And
if we
then
can
here.
turn it against certain.
So you have dx on this side, so you multiply by dx.
Yeah.
So integral u to the fifth.
I believe so.
dy over dx, and you multiply by dx. So the dx on that side cancels.
X squared
You get
dx.
x on?
Where are you? Why are you trying to cancel it here?
What is x squared dx equal to?
Okay, no, like, so, yeah, here. This is the same as
Now you gotta all turn to u. It looks like you started to integrate.
That's the same.
You have it written.
Do you see
I thought it
that?
all in terms of
Okay,
u.
so then,
Rate
so now here,
15.2.
we can have dy, and then if we multiply this by dx, we multiply this by dx, so 4x dx.
Okay.
And then we have to multiply this one by dx also, so it's 4x dx. So then,
Okay, I
4x
got
dx
that
is
right.
our
So
negative 2 du.
there's a
So we have
2x squared
dy
somewhere.
equals negative 2 du plus negative 2.
Part of it.
Integration now u.
There's a 2x squared that we're.
I was just thinking, change that to y prime. Antiderive 4x, which is 2x.
I think this is how it changed.
But how come, what if you just do this?
Okay,
and
wait,
find
wait,
that?
I think I figured out.
Multiply
Just
this together.
I think I figured out what we did.
And then you add
I
it on
figured out what we did wrong.
to the 2x.
4.
We don't mess with this term at all, we just mess with
Okay.
this.
And replace u with.
Oh, because
u
this
was-
isn't being multiplied by the dx, it's only this.
So what is the point of finding any of
I
this?
don't know if that's right or not, let's see.
And you do, you're gonna plug it in right here.
You said plug in the U.
So we have to, we just have to get
So down here in your
four
answer,
DX now.
one question, like it just happened.
Oh, because there's not a DX or 4X DX?
Like, why do you have to do any of this?
Sine of pi is and pi sine of
I don't know if that's right.
So it's
It's
dy
dy
multiplied
by dx.
4x dx. Pi.
Oh, so look at this as a derivative. If we brought this
You just
down.
go ahead and put
this goes to
u,
plus
u.
three. So derivative of the constant goes to zero. The derivative of this should bring this down. That would become what?
So next you did 4.
4x.
Negative 1/3. Okay. This up to the fifth. Times.
That's on you.
Is this
That squared minus the y squared is gonna cancel out the 1/3 you got there. And all that you gotta do is, I think you were doing it fine, but when you were writing this step that I had to erase. Like you started,
I'll try.
you started to erase without, you had made that, you need one line.
You're actually the answer.
Before you try to
2x
figure it
squared
out.
minus 4 times square root of 16 minus x squared. A
Just getting well, there's only a differential equation. There's just gonna
Yeah,
find
yeah,
it.
yeah, yeah, I got it.
So if you integrate that side, you get y.
No.
Yeah.
You're on 33. No, I'm on 27, dude.
Integrate y prime, you get y. So the left side is done. To integrate this, you don't need any substitution, you should just be able to do that quickly.
No.
And in the right term.
Did you do 27?
you have to-
No, I'm still on it. I just skipped it. I'm like I'm going back and forth.
Saw his hand first.
So.
Your number.
Oh, yeah, I thought you said you saw mine.
I thought he was.
I'm so close.
Cause like that's on the bottom, so I don't really know what to do with it. Like the denominator should be.
You just,
ignore that. This is
Integrate y prime, you get y.
See?
Okay, go.
There's a fraction.
Integrate 4x.
16 minus x squared.
Let me see.
2x.
Yeah, we don't need your substitution.
You can separate this into going to the work.
why would 4x?
And it will make
I
it
guess I can
easier.
make that.
You can separate it. Yeah. Basically, if it's plus or minus, you can
So
separate
if you
it.
integrate multiple terms, you can do them separately.
Oh, okay.
So just do the 4x without your substitution.
Okay, so like this is not being multiplied by the, this like dx is not being multiplied by the entire thing, it's just this term right here.
No, it is. But you can't integrate without some.
So what did you do for you? 16 minus x squared?
Yes.
But it's like you're integrating
So
this
du is equal to negative 2x dx.
plus, you're integrating
Well,
this.
Negative 2x dx.
So then rewrite this with your new spot.
Yes, negative 2x dx.
So finish that last term with
And
this.
then did you multiply by negative 2?
Might be hard to see.
So, yeah, and then let me check that
Get your stuff back up.
Not gonna
Yeah.
Oh, okay, so you brought algebra. I think I drew algebra.
What's the unit?
Thirty-three myself.
So the rest you raise it to 1 times because you added
33. Oh, hey, would you look at that? What would you say?
So like you can,
And what is
you can just integrate this over x without substitution or substitution or
yeah.
it's its own separate thing.
Well, yeah, I got that. Just 2x.
I'm not saying that's not possible.
Hey, hey.
You got to remember the negative 2. going with that.
Integrate.
Oh wait, it would be 2 u to the 1/2 multiplied by negative 2, so it would be 2x squared minus 1 to the power.
Oh wait, I know, I got four actually. I got four. Yeah.
Alright.
Cause you got the
Trying to
thing
do
where
all of
you
that at
apply
once.
it, you know.
I've been
And then
in
you
so
just
much
plug
almost impossible.
scholarship applications for so long. I've just lost my critical thinking.
I believe I'm on the right track. So I did,
Maybe I should probably
only,
too.
you need mostly to separate it into two.
I actually should have done it too. I don't know why.
That's this one.
Yeah, I know.
That's why you have negative substitution.
And then I didn't do substitution. And then I multiplied by the two, so I put -2 on that side of the equation. I got
Did you get negative cosine by negative? Yeah.
Oh, I already
Good job, man.
put it,
We did take a, that's it.
oh, I see what you mean.
That was perfect.
I think you said integrate. I think this is like u to the negative 1/2.
No, this needs to be
d.
1/2.
And I have
Then that one multiplied to 4, right?
I don't know, I can't follow.
2 times negative 1/2, or negative 2.
Too much for me. I think what you may be doing is trying to
U is-
you're either not integrating or you're not writing integration symbol when you haven't integrated. You're skipping something.
Houston, we get. I need to.
Okay, guys, we need to find a stopping place. I got 2 things to remind you of. One is I do want you to try the rest of these 8. Please come by on Tuesday during advisory if there's some of those holding you back. This is a thing we're going to stick with for a while, so the sooner you start to feel that you've got a grasp of it, the better. Don't forget about the 2-question mini quiz. 2 questions come straight from the notes. And then third, keep in mind that this semester we do not have a semester exam like we did last semester, and a lot of you guys brought your grade up quite a bit with that grade replacement. So we can't offer that this semester because we don't do a semester exam. But we do offer 1 grade replacement, but it's going to be on our next assessment because it will be over Chapter 5, stuff we did earlier, plus U substitution. So that will be the only grade replacement of the semester to keep. So I wanted to give you a heads up on that. But we're out of time. Have a good weekend.